So hi everyone, and welcome to what's probably going to be the last video in this project. It is going to be a demo of the project. And just to recap, what you can see on the screen now is our physical setup. So on the left we have the receiver, which has multiple radios. In particular, it has Bluetooth for receiving data from the beacon, which is on the right. LoRa to send the data up to AWS uplink via TTN, and then on the left side you can also see a GPS receiver, which we use to obtain position and timing information to tag all the received beacon pings with. All the boards are marked as on the screen, and the full project files are available on our GitHub repository. Let's start with just running everything. So we will see the output on the serial console of the receiver. The beacon is continually sending pings. We are using some power saving techniques, so it's sending pings for a few seconds, then sleeping for a few more, but overall you will see a relatively constant stream of pings. So let's go on to the video and see what happens. So here we are flashing and then starting the receiver. The beacon is already running and sending pings. We verified this via a mobile phone. We could see all the packets and it was working. So let's look at the receiver. So here we are flashing the receiver. It takes just a little bit of time. It's already compiled, and once it's running you will see the startup procedure and everything else. So here we just reset the receiver. You can see the GPS parser starting and the LoRa connection as well. It's printing some identification data. Once the LoRa connection is initialized successfully, we also start the Bluetooth section of the code, which is a separate thread. And in the meantime, the GPS receiver, GPS parser is continually receiving data, and whenever we get a lock, we update our position and the current timestamp. Then you can see all the beacon IDs that are received. These are the beacon IDs. Well, it's always the same in our case because we only had one beacon, but it's all the beacons that we received in that period. And then periodically we take all the collected beacon IDs. You can see two packets of this kind whenever it says sending, and then there's the big JSON. The first time we are only sending the first two pings, and then everything else. So in this solution we are sending every ping that came after the last time we sent data over onto LoRa. Generally we found that this works decently well. Of course there could be optimizations in how the data is collected, but the solution is currently working. And you can see that the data is tagged with everything else. Finally, we can see that the packets are received on TTN and can be fully utilized for any algorithm.